Hi everyone, my name is Vikram Kulkarni. I work for GL Communications. Thank you for joining us on this webinar. I'm joined on this call by two of my colleagues. Prasad Maya is our senior engineer working out of our Bangalore, India office, and Sanjeev is our sales director also working out of our Bangalore, India office. Again, my name is Vikram and I work out of our Gaithersburg, Maryland, USA office. We're hosting this webinar today because we're very excited to tell you about the launch of our latest product, the PacketExpert 100 gig. A lot of you that are joining us on this call are already familiar with GL Communications. If you're not, we are located in Gaithersburg, Maryland, United States. That's our office building right there. We've been around for over 30 years, and we are a telecommunications consulting company. So we do a lot of consulting work for private clients and for local and state government as well. In addition to our consulting services, we manufacture our own hardware and software. And this equipment is tailored towards test and measurement in the telecommunications industry. So our hardware and software can test networks. And when I say networks, I mean all different types of telecommunications networks, whether it's your public switched telephone network, whether it's legacy networks like that, or T1, E1, T3, E3 networks. We can also test Ethernet and IP networks, which is the subject of today's webinar. We also have test solutions for wireless networks. When I say wireless, I mean 2G, 3G, 4G, 5G solutions. We can also support land mobile radio. We support fiber optic networks like SONET and SDH. So basically, our test equipment can test all these different types of networks, and we can monitor these networks. We can do protocol analysis over these networks. We can visualize the data traversing these networks. We can capture the data. We can store the data. We can replay data. We can simulate data, simulate different protocols as well. We have a lot of different types of testing and measurement solutions for these networks. So we don't build the networks, but we test them. That's just a little bit about us. We sell our solutions to all sorts of different companies, service providers, equipment manufacturers, defense contractors, government agencies, basically everybody that's involved in the whole telecommunications space, we've done business with at some point or another. So now that's an overview of who we are and what we do. I'd like to now talk about our today's topic, which is Ethernet and IP testing. So let's kind of talk broadly about the whole scope of Ethernet and IP testing. Customers come to us with all sorts of different testing requirements. Some customers wish to test individual network elements, isolated network devices. This could include cables, switches, routers, gateways, and so forth. A lot of our customers have custom-built cables or switches that are designed for special purposes under certain conditions. So our test equipment can test isolated devices. Gateways, when I say gateways, I mean things that can support multiple interfaces. Maybe on one side is an analog connection, and on the other side is an IP connection, or a T1 connection, or something like that. So gateways are basically devices that can translate from one protocol or one interface or one communications technology to another. So we can test isolated devices like these, but we can also test end-to-end network paths. So we're talking about wide area networks, one geographic location to another. You know, from anywhere to anywhere else in the world. Anywhere you've got an IP connection, you can communicate. We can be at those endpoints, and we can measure that network path. So we can be deployed in the field. We can be deployed in the data center. We can be deployed anywhere in between. So that's a little bit about what types of stuff we can test. The next question is like when to test, what frequency to test, under what conditions are we testing? If you're just testing an isolated device in a lab environment, then it's pretty simple. But if you're testing a some sort of operational device, maybe something that's actually being used, then maybe you need to test at only a certain time of the day. Or maybe you need to test under high or low stress when the device is being highly utilized or underutilized. Maybe there's certain times where you want to test the performance of the device. Maybe after there's been some sort of infrastructure change or some software upgrade to your system, and you need to test again after this change has been implemented. So that's another time when you want to test something. If there's any sort of circuit handover from a service provider to another service provider or to a client or a customer, anytime there's some sort of handover, you want to test before and after the handover to see that everything is functioning correctly. Acceptance testing, benchmark testing, these are all things that can apply for like isolated devices and so forth. Okay, so now we want to know how to test these types of devices and networks. We can test at many different layers and levels. We can look at fundamental statistics like bit errors, just wanting to know how many ones and zeros did we send, and how many ones and zeros did we get back, and how many bits were flipped. We can do bit error rate testing. A lot of times that's good enough if you're just wanting to do a simple cable test or test a switch. Bit errors are really what you're going for. We can go a little bit higher, and we can look at packet loss, frame loss, throughput, latency, one-way delay, round-trip delay, jitter, all sorts of different statistics at the packet level. We can test Ethernet. We can go to higher layers like IP, UDP, TCP. We have different types of applications which can do these types of higher layers as well. So those are all things to consider depending on what type of application you're looking for. And this final bullet here, you want to test. A lot of times you want to test under different conditions. So you want to test at different types of throughputs. You want to test at different types of frame sizes, different types of packets, different protocol headers, different quality of service parameters and things like that. So what you'll find is that a lot of network equipment will behave differently when you test it at these different types of speeds, frame sizes, packet types, and so forth. So this is kind of just an overview of all the different types of things you want to think about when you're testing an Ethernet or IP layer, an Ethernet or IP system or network. Hopefully this kind of covers some of your different testing scenarios. Let's move on and now talk about some real world examples. So like I mentioned, we have a lot of existing customers, and they all want to do different things. So one common requirement is service level agreement verification. So SLA stands for service level agreements. A service provider, when they're providing any sort of network or service, will provide certain conditions which they guarantee to meet. Committed information rates and excess information rates and things like that. So you want to be able to verify that what you're getting, what you're paying for is what you're getting, basically. So service providers will want to verify their own circuits and networks. The customers will want to verify these networks as well, independently. So SLA verification is a very common request that we get from customers. Okay, that's for like end-to-end network paths. We also get a lot of different equipment manufacturers, and they're always building custom-built equipment endpoints and cables and switches and things like that. So they want to test during development. They want to do regression testing, which is like longer-term repeatable testing. And they also maybe want to do some sort of production testing, making sure that equipment is ready to go, ready to be shipped and so forth, or ready to be mass produced. So individual equipment or end-to-end network paths. Okay, the third bullet here, data center testing. So the whole world is running on data centers these days. Web servers, file servers, computational clusters running complex calculations and so forth, all sorts of hosting services and cloud sharing, cloud storage, and so forth. These data centers are processing an enormous amount of data at very high data rates, 100 gigabits per second and above. These data centers are talking to other data centers, and they have to be able to talk at these super fast data rates. So customers come to us and ask to deploy our equipment in these data centers and run end-to-end tests, or within the data center from one node to another, make sure that the interconnects are behaving properly. We get customers with all sorts of special requests. One is like precise delay testing, precise timing. They want to know exact, with nanosecond accuracy, what's the times for packets traversing the network from point A to point B, exactly what type of timing they're getting. And then we also get like requests for simulation, for traffic generation, or network emulation, simulating networks with high or simulating networks with high packet loss or low throughput or long delays and things like that. We can also emulate these types of networks. So customers ask us, hey, can you simulate some sort of network that has 500 milliseconds of added delay, or a reduced throughput of 50% of what it should be, or 3% packet loss. We get requests like that. So and this is just some examples. We get all sorts of different types of examples, different types of requirements. And so again, depending on whatever your requirement is, please come and talk to us, and I'm sure we have a solution which can help you. Okay, so next slide. There's a bit of a delay, so I realized when I transitioned to slides. Okay, so now we want to ask the question, what type of testing device is needed? Whatever you plan to use, there's some common themes with any sort of test device. First off, you probably want it to be very flexible in terms of what type of interfaces it can test on. Ethernet has really evolved rapidly over the last couple decades. You have 10, 100, 1000 meg Ethernet networks, but as time has gone on, you've gotten faster and faster data rates and therefore different Ethernet standards. 2.5 gig, 10 gig, 25 gig, 40 gig, 50 gig, and 100 gig are now common Ethernet standards that are deployed in a variety of scenarios. So customers usually want to test at a lot of these different interfaces. So you want a test device which is versatile, which can have all these different interfaces on it. You want different customers want portable solutions, and some want rack mountable solutions. Some want to deploy this test device in a network room or a data center or somewhere and just install it there and never move it or never touch it ever again. Other customers want to deploy this out in the field, run a test, pack it up, fly out to a different site, again, unpack it, set it up, run the test, and move on to the next site. So some customers want a portable solution. You want to be able to cover many different types of tests. Bit error rate tests are the most fundamental tests, but you may want to go beyond that. You may want to look at packet type statistics like RFC 2544. You may want to look at TCP specifically, so RFC 6349. You may want to look at service level agreements. So ITU-T Y.1564 is the standard for that. You may want to do other things like capture packets, filter packets, playback packets, generate multiple streams of packets, simulate impairments. So you want a test device which can cover all these different types of testing scenarios. You may want to automate your testing. You may want to run scripts, especially if you're doing repetitive testing over and over. If you want to run hundreds of tests, you don't want to simply start and stop a test manually and then keep clicking over and over again, start, stop, start, stop. You want to be able to script your test. So that's one requirement customers have. You may want a convenient graphical user interface. Maybe you don't need scripting. Maybe you just want a comfortable graphical user interface. And that's perfectly fine. In fact, the majority of our customers just need a simple graphical user interface where they can point and click, set up IP addresses and MAC addresses and VLAN tags, things like that. Start and stop the test, view the real-time results, export the reports, and so forth. And finally, obviously, you want a cost-effective solution. So these are the different types of considerations when you think about your test device. Okay, so many of you are familiar with GL Communications. We've been selling our PacketExpert 10GX for a very long time now. It's probably our most widely sold product in our portfolio. It is everything that I just mentioned on the previous page, this PacketExpert can do. It's flexible. It's got all these different interfaces on it, RJ45 connections. It's got SFP cages, 10, 100, 1000 meg, 2.5 gig, 10 gig, single mode, multi-mode, copper, you name it, it can do it. It's portable, lightweight, connects to a Windows PC through a USB connection. Very easy to install and set up, lightweight, you can hold it in one hand, and so forth. It can do all sorts of different types of testing, bit error rate testing, loopback, RFC 2544, capture and playback traffic, generate multiple streams of UDP traffic. It can do TCP testing through RFC 6349, whiteout 1564, impairment simulation. So all of these different types of testing, the PacketExpert can do it. It's just simple licenses. You can buy licenses all at once. You can buy them independently as you need them, or just focus on the licenses that you need. Very flexible licensing scheme, and so forth. So this is our PacketExpert 10GX. It's very nice. The only drawback it has is that it can only go up to 10 gig. Customers nowadays are looking to go to higher and higher data rates, especially when we're talking data centers and very, very fast optical networking equipment. So we're talking 25 gig, 40 gig, 50 gig, 100 gig Ethernet networks and beyond. PacketExpert can only go up to 10 gig on these two ports here on the right-hand side. So that's the only drawback of the PacketExpert 10GX. So now, finally, without further ado, let's talk about our latest and greatest offering, the PacketExpert 100 gig. The PacketExpert 100 gig has just been released. Just a few months ago, we released it. It is a radically different design than the PacketExpert 10GX that I just mentioned on the previous slide. The PacketExpert 100 gig is a full-blown PC, rack mountable or portable. We have different form factors. I'll go over them on the next slide. And it is very versatile. You can put up to 5 network interface cards into the PC. Each network interface card has 2 ports, and each port can go up to 100 gig. So that means you can go really high density and put 10 100 gig ports in one PC if you wish. So very flexible in terms of the number of ports. I'll talk about SFPs a little bit later. This network interface card is specialized. It supports 1 gig, 10 gig, 25 gig, 40 gig, 50 gig, and 100 gig. All these different data rates, it supports it on the same network interface card. It's a different design also in terms of the user interface. The PacketExpert 10GX, it had a desktop-based user interface. Here, we'll show you some screenshots of our new user interface. It's a web browser-based user interface. It's actually much easier to use. It's a browser-based interface. I'll show it to you momentarily. You can access it remotely. Here we just show some, you can access it through a tablet or laptop. Again, it's a browser, so it's very convenient. You can just open it up on a browser to access the software and fully control all of the ports. Multiple users can log in to this software simultaneously. Unlike our previous PacketExpert, because this is a web browser, it can support multiple different independent sessions. Each user can reserve ports for their own testing. So you can have one user reserve a couple ports, another user reserve other ports, and so forth. So multi-user support is now available on the PacketExpert 100 gig. Now, when I say 100 gig, it's full wire speed, bidirectional 100 gig, full duplex traffic. So it's you're not going to lose packets. It's full wire speed, 100 gig. I'll talk about applications momentarily. It's very versatile. We've implemented bit error rate testing, Loopback, and RFC 2544. As I'll mention later on, we are almost about to release some of the other applications that are available on the PacketExpert 10GX. We can support jumbo frames, 64-byte frames, all the way up to 16,000-byte frames. We can test at the Ethernet layer. We can do VLAN, MPLS, IP, and UDP. Just like the PacketExpert 10GX, we can do all of that as well. Also, we are about to release the Python APIs, so you can do Python scripting to fully control the PacketExpert 100 gig, again, just like the PacketExpert 10GX. So that's a little bit about the PacketExpert 100 gig. Let's now go into whoops, sorry, my computer kind of slowed down there for a second. Now let's talk. Let's go a little bit more in depth about the PacketExpert 100 gig and what it can do, and the form factors. So, like I mentioned, we can support portable form factors. Here we show a couple different portable form factors. If you just need 2 ports, then we can put it in a pretty narrow Lunchbox PC form factor, like you see here on the top left. But then again, we can scale up to multiple different ports. Here we show a system with 8 100 gig ports. And so as we make the system bigger, we have to increase the SSD, increase the cooling, the RAM, and so forth. These are custom-built PCs. We have put a lot of thought into the design of them. We've optimized the cooling, the storage, the RAM, the processing, the writing to disk. We've put an enormous amount of thought and time and effort and testing, and so we are very confident that this solution, you can write to disk, you can capture, you won't lose packets, and the system is stable, does not overheat. It's a very, very reliable long-term solution for Ethernet testing. We also have rack mount solutions. So these bottom 2 pictures are the rack mount solutions. So if you need a rack mount solution, we can support that as well. Again, if you just need 2 ports, it's a pretty narrow 1U high solution. If you need more ports, then it goes up to about 7U. So that's a little bit about the form factor. Okay, so just like on the PacketExpert 10GX, we support bit error rate testing, RFC 2544, loopback capabilities, and very soon we're going to release the Y.1564 testing standard for verifying service level agreements. We're also releasing Y.1731 for operations and maintenance type testing. We'll talk about that a little bit later. And then we're also releasing this precision time protocol support, as some customers have asked for very precise one-way delay measurements. So we have in the pipeline 3 more applications that are going to come very, very soon within the next few months. So be on the lookout for that. We'll release a newsletter when we release them. Okay, so let's talk a little bit about different types of testing scenarios. This is a very simple depiction of a simple testing scenario. Let's just say you have a PacketExpert at one location and a PacketExpert at another location, and you've got some switches and then maybe multiple routers in between. And so you want to do an end-to-end test over this IP network. So what you would do is, again, you deploy PacketExpert at the endpoints, and you can simply run a bidirectional bit error rate test at the IP level. So in that case, this PacketExpert on the left will construct IP packets. It'll go to the local switch, which will go to the router and all the other routers in between, and then end up on that on the far end network, where it then gets switched to the far end PacketExpert. This PacketExpert will measure the bit errors. Very easy to set up. You set up the same bit patterns on both sides. It knows the bit pattern. It knows the expected bit pattern. and it will compute the bit errors. Simultaneously, it can run its own bit error rate test, sending independent streams of packets through the network and back towards the near end. And again, you can get the bit error results in that direction as well. So you can get bit error rate measurement in both directions simultaneously. If you're going through routers, you need to go to the IP level. If you're just going through switches, you can stick to the Ethernet level. Besides bit error rate testing, you can also do RFC 2544 testing, exact same type of test setup, but it measures things a little bit differently. It'll measure throughput, packet loss, latency, and so forth. So this is one type of testing scenario. This is very simple. It's just one router, but you can scale this up over an entire and wide area network path. Okay, so that's one testing scenario. Another simpler testing scenario is where you want to test some sort of custom built switch or device in just a lab environment. In that case, you don't need two packet experts, you just need one. And you are basically connecting both ports through the switch. And the packet expert is going to send traffic through that switch, which will switch it back to the other port. Again, you can do bit error rate testing, or you can do RFC 2544 and measure the full performance of that switch. You can really push the switch to the limits. So if this thing claims to be a, 25 gigabit switch, you can push it to all the way to 25 gig and make sure that it's actually not dropping any packets at 25 gigs bidirectionally. Make sure that it's not introducing bit errors and so forth. So you can really stress test and push the bounds of your networking equipment with just one packet expert device. Most of you are probably familiar with RFC 2544, but if you're not, you can certainly ask questions about it, and we can discuss it more. This is, I just want to mention we can also do latency. This was already talked about, but we can do latency measurements. In latency measurements, if you're going over a full network path, then what happens is the packet expert on the near end will put a little timestamp in the packet, send it over the network, and the packet expert on the far end will just loop back the packet, meaning it'll just swap the source and destination MAC address, source and destination IP address, and send that same packet back over the network to the near end packet expert. And the near end packet expert sees the timestamp that it's sent out, compares it to the timestamp when it receives it, and therefore can do a precise round trip delay measurement. And when I say round trip delay, I'm talking nanosecond accuracy. So we have nanosecond accuracy on this round trip delay measurement. We can do one-way delay. If I go back for a second, we can do one-way delay if you're just going through one packet expert. Here, it's the same packet expert, so it's just going to timestamp it, send it through the switch and back, and then measure the time when it receives it, and then it can get you a one-way delay measurement through the switch. The problem is if you have two packet experts at different locations, then you have to go through a special process to synchronize the clocks in order to get a one-way delay measurement. And that's doable through this PTP, Precision Time Protocol, which we are now in development. So we are developing precise one-way delay measurements through a network path. Okay, so Sanjeev is telling me that I need to speed up since it's already 36 minutes into the presentation, so I'm going to speed up a little bit. I'll just briefly mention loopback. Like I said, loopback means, in this context, loopback means that when the packet expert receives the packet, it will swap the MAC addresses, source and destination MAC addresses, source and destination IP addresses. And if you're using UDP, it'll swap the source and destination UDP ports and simply send the same exact packet right back through your network. It will do this without loss. So if you're blasting out 100 gig traffic from one PacketExpert, this PacketExpert will loop it back without loss through your network. And you want to set up a loopback scenario where in situations where you have a far end PacketExpert that you just want to kind of leave alone. It's out there somewhere in the field and you just want to leave it in a loopback mode and then forget about it. And with your near end PacketExpert, you want to do all of your measurements. So the near end PacketExpert is where you're setting up the test and then blasting out the traffic, getting it back from the loopback device, and then doing all the measurements. So that's what we mean when we say loopback. So we support loopback. It makes it very easy to do like testing over a wide area network. You just deploy this one out in the field and forget about it. I will skip this slide since, yeah, this is what I just talked about. Okay, so I'm sure a lot of you are thinking about SFPs and transceivers and which SFPs do we support and which cables do we support, and are you compatible with this vendor and that vendor, and so on and so forth. The simple answer is yes. We have extensively tested across all sorts of different SFPs, across all sorts of different rates, single mode, multi-mode, all sorts of different types of connectors. We've done the hard work of making sure that our solutions are compatible with all the vendors out there. And when you come to us and you talk about your testing requirements, we can provide the SFPs and the cables and all the accessories for you. It'll be one, self-contained, ready-to-go solution. So we can provide all of that for you, or you can use your own. We can talk about, we'll tell you, precisely what type of SFPs and cables you need for your specific type of testing requirement. I'm not going to go too far down the rabbit hole here, but again, we've done the hard work. We know which SFPs and cables and all that we're compatible. We're compatible with basically everything, and we can supply them to you with the PacketExpert system so that you get it. Everything's ready to go, plug and play, and you don't need to think about it too much. Okay, so as I mentioned before, the PacketExpert 100 gig is now controlled by a web. The software is now accessible through a web browser. So there's a web server running. The web server can be deployed on the same computer as the PacketExpert, or you can deploy it on a separate system. We would supply the software to you, and you can just install it on a separate server. Why would you want to do that? Well, let me show you. Oh, I think I don't have that web page. That's probably later in the presentation. But you can imagine if you have multiple PacketExperts, then you can have them all be controlled by one web server. So that way, one web server is talking to multiple PacketExperts, and then multiple users are logging into that one web server. So that's very convenient. You get multiple users logging into one web server, which can be controlling multiple PacketExpert devices. Okay, so I don't have much time left. So what I'm going to do on the following slides, I'll just kind of fly through some screenshots of the actual server so that you can kind of see it in action. I won't, it's not too complicated, but basically you log in to the server. Again, it's a browser-based application. Just log in with whatever username and password that you set up. And then once you access the system, you can access multiple different servers, multiple different packet experts, and control multiple different systems simultaneously. We've built this so that it really scales nicely for different, so that you can really control multiple systems out in the field. You can reserve a device. If you have multiple users accessing different devices, you can reserve a device. You can check first off that it's available. You can click on any system. You can get information on its MAC addresses, its current temperature, the all sorts of different things. What software version it's running, the serial number of that device. All of it's there through the web-based interface. You then can select whatever data rate you are looking at. 1 gig, 10 gig, 25 gig, 40 gig, 50 gig. You basically just set it yourself, and then you set the application through the drop-down menu, whatever application you're running, whether it's bit error rate testing, RFC 2544, and or so on. Again, these are all. It's just very easy. It's just simple drop-down menus. It's very intuitive. On my first time going through the web-based browser, it was pretty clear and pretty easy to just kind of see and just click from a drop-down. You can, for every single port, you can get more details about the port. Again, MAC addresses and so forth. You can get its status. Green indicates that the ports are ready and available, they're connected and ready to go. Red indicates that something is wrong, the port is down, and so forth. So for every port, you can know exactly what its status is. Here, this is a slide I thought was a little bit earlier. This is the idea that you can control multiple different packet experts from one web server. All packet, as long as you have an IP network set up, IP management network set up, where all of these servers, where all of these systems can talk back to a central server, then you're good to go. And then that server is accessible by multiple different users. So that's what I meant when I say multiple users, multiple systems. Okay. Again, in this screenshot here, we're just showing multiple different devices. This is a situation where we have 3 different PacketExpert devices, and you will see all 3 of them as soon as you open up the server software. This is more details about the NIC, the network interface card, as well as the SFPs and the connectors. I'm not going to go into it too detailed. It's a little self-explanatory. But again, it's very easy to get confused by all these different types of SFPs and connectors, and making sure you're using the right connectors to the right SFPs and things like that. So you can always ask us, and we can always tell you precisely how to set everything up. So yeah, so that's this. This is just talking about the 1, 10, 25 gig configuration. These ports are multi-rate, so they support 1, 10, 25, 40, 50, 100. But when you change the rates, you may need to change the SFPs, depending on whether you're using multi-rate SFPs or single-rate SFPs. Okay. More snapshots. This is showing, setting the rate to 25 gig, setting the IP addresses. We support IPv4 or IPv6, setting the gateway, the subnet masks, and all that. Very easy to do. Let me skip that. Let me go. Yeah, more details about each port, what the SFP is, its MAC address, IP address, and so forth. I mean, we provide a whole host of data on the SFPs when you connect them. The wavelength, the maximum length, the signaling rate, the encoding, what specific Ethernet standard. It'll read all of that from the SFP. So when you plug it in, you'll see all this information. Okay, let me go ahead and skip over this. Okay, so now what I want to talk about is when you're running your testing, you get very easy to digest graphs straight from the web browser. We're showing the throughput. I apologize, the resolution on this snapshot is a little low, but we're showing the throughput. We're showing total number of bits sent, total packets sent, total number of bit errors. We have LEDs that go yellow or red if there's bit errors. If you wanted to insert bit errors just to see what that would look like, you can insert bit errors intentionally, and so forth. So basically everything you could do with the PacketExpert 10GX, you can do with the PacketExpert 100GB in terms of our bit error rate testing capabilities. It shows you the throughput and link utilization, and so forth. More snapshots. Here you can click on bit error rate results, get more details on the bit error rate, the current rate, the average rates, all of that stuff. Real-time graphs. We can also plot the bit errors as well. They'll show up as red dots in the graphs. A whole host of different data on each port, all the total number of frames sent and received, what type of frames these are. Are they just IP frames? Are they UDP frames? Do they have valid frame check sequences, invalid frame check sequences? Do we have any, it can tell you all sorts of details on the frame sizes. Do we see any VLAN tags? Do we see any MPLS packets? Do we see do we see any checksum errors? All that type of stuff. I mean, it's just, you can go on and on in terms of the total number, different type of packet statistics you can report. You can export all of the data to a PDF or CSV file format, just like with the PacketExpert. Now, one advantage is that we can actually export the reports while the test is running. Before, with the PacketExpert 10GX, we had to stop the test and then export the report. But actually, with the 100GB, I believe we can actually export the report at any time, even while the test is running. CSV or PDF file formats. Everything that you saw in the web-based GUI will be exported to a report. Graphs, statistics, everything. These are aggregate statistics over the lifetime of the test. So total bit errors, total bits sent, total packets sent, things like that, out of average throughput and so forth. I'm going to skip over this. This is just more about setting up like loopback tests and so forth. I can skip over that. This screenshot here is for RFC 2544. It's basically the same type of thing. Let's see. Yeah. So when you're doing RFC 2544, you can set different types of frame sizes, and for each frame size, it will run through a series of tests. It'll determine the maximum throughput it can achieve without dropping packets. It can determine the round trip or one-way delay. It'll determine the packet loss for predefined throughputs that you set, and it can do burst tests as well. So everything in the RFC 2544 standard, we support it. Oops. Yeah, this is setting up the test, setting up the throughput, latency, packet loss, and back-to-back test parameters, and then viewing the results, the throughput results, latency results. Here, I'm sorry, this snapshot has small fonts, but we're plotting it in microseconds, the latency, but you can see that we have nanosecond precision on the latency measurement for all the different types of frame sizes. So it's always good to know, okay, what's the throughput for different types of frame sizes, because your device could behave differently for smaller frame sizes versus larger frame sizes. Okay, it's already 12:52, so I'm going to go through here pretty quickly. You can view the graphs for the throughputs, for the latency measurements. You can view the graphs in both directions, east to west, west to east. You get independent results in both directions. As I mentioned, we're going to soon support Y.1564, which is an industry standard for verifying service level agreements. Things like committed information rate, excess information rate, any sort of testing for any sort of traffic policing, and so forth. This is a multi-stream test, so you can actually send multiple streams of traffic simultaneously. And each stream of traffic can have different frame sizes, different quality of service parameters, different packet types, and so forth. And you can and so you can do them all simultaneously. And for each one, you can get independent statistics and measurements. We are soon going to support Y.1731, operations administration and maintenance of Ethernet networks. This standard is for basically determining faults. It sends out different types of control signals onto the network and makes sure that other network equipment are responding to those control signals properly. So you can determine things like link failures and loss of signal and so forth. This is soon coming as well. And the Python scripting is the last thing I want to mention. I don't think any of our competitors support Python APIs with the type of flexibility that we provide. Our PacketExpert 10GX, or PacketExpert 1G, and soon our PacketExpert 100 gig support Python APIs. So everything you can do through the web browser, you can also do through a Python script. Imagine how much flexibility you now have. You can run tests over and over again, go through hundreds of different testing scenarios, export reports as frequently as you want, export data as frequently as you want, save the data as frequently as you want. Because you can do I mean, it's really the full flexibility of scripting is at your command here. And the nice thing is that you don't even have to run the Python script on this system. You can run it on any PC that's connected on that same LAN, or any PC that can somehow, through TCP/IP, talk to that PacketExpert. So this PacketExpert will be running some background server, listening to API commands, and then from your laptop PC somewhere else on the network, you can run the script and it'll execute those commands, start test, stop test, and so forth, and the PacketExpert will go ahead and do it. So the Python scripting is really one of our biggest advantages over our competitors, and quite frankly, I don't think our competitors do offer Python scripting. We provide sample Python scripts. We can help you get started. We provide API user manuals and so forth. Let us know if you have any questions. Please email us questions at info@gl.com. If you haven't already, please subscribe to our newsletter. You can just go to our gl.com website and just click on newsletters and you can subscribe. Thank you all very, very much for joining us on this webinar. We really appreciate your time. Don't hesitate to contact us, and please enjoy the rest of your day. Thank you very much.